Hello everyone, my name is Abhishek Sawarkar. I'm a product manager in the AI Enterprise Software Group at NVIDIA. In today's session, we'll discuss the industry trends in AI, provide an overview of NVIDIA AI software, and also talk about NVIDIA AI integrations within Azure services. So let's get started. In this section, I will share some of the AI trends and also how enterprises are using AI within their businesses. By 2026, IDC projects that 60% of organizations will be actively using AI-driven features embedded across a broad range of business technology categories. Some of the prominent sectors that will see the most impact of AI are human resources, IT and security, customer service, and product development. To highlight one, a lot of enterprises are adopting chatbots and virtual assistants powered by AI today to respond to customer service requests and reduce customer wait times. AI will be pervasive across the whole organization going ahead. Today, generative AI is revolutionizing various aspects of businesses, enabling organizations to leverage its capabilities for enhanced productivity, customer engagement, and innovation. Generative AI agents like ChatGPT are capable of generating text, language translation, and even coding. Chatbots equipped with generative AI can engage in natural human-like conversations, providing efficient and personalized customer support. By embracing generative AI, organizations can unlock new opportunities, drive innovation, and gain a competitive edge in today's fast-paced and evolving market. Now let's examine the different types of generative AI we are seeing across the enterprises. We have mapped it on this chart to illustrate that generative AI and the customization requirements that different customers have fall across a spectrum. We are at a phase in the adoption cycle when most organizations are starting to experiment by consuming foundation models which are off the shelf, like ChatGPT, Google Bard, or Amazon Bedrock. However, the biggest value for many will come when they customize or fine-tune their models using their own customized data to address their unique needs. Customization can broadly be defined into three categories. Low-level customization, which is using prompt engineering where original model weights are not changed. Moderate customization, using parameter efficient fine-tuning methods, and extensive customization, where fine-tuning foundational models or extensive customization takes place. An example is Bloomberg GPT, built entirely from the ground up. These types of engagements involve substantial infrastructure, resources, and investments, with projects often taking upwards of 6 months. NVIDIA has been advancing the art of AI for over a decade, helping organizations both pilot and move to production with AI workloads. NVIDIA AI platform includes over 450 SDKs and AI models, which are being used today by 14,000 AI startups and over 4 million developers. NVIDIA has many supported GPU instances available on Microsoft Azure Cloud that include the NC series with the NVIDIA V100 Tensor Core GPU, NC T4 series with the NVIDIA T4 GPUs, ND A100 and A10 based on the NVIDIA Ampere GPU architecture, and the latest and the greatest ND H100 V5 with the NVIDIA H100 GPUs. The NVIDIA AI Enterprise software supports past, current, and future GPU infrastructure to foolproof your AI platform and maximize the GPU utilization. All the latest software optimizations get you the most bang for your buck, reducing your total cost of ownership of the NVIDIA stack. In this next section, I will provide an overview of the NVIDIA AI platform on Azure. NVIDIA AI Enterprise is production-grade software for AI, and it includes the following benefits. Accelerated computing. It increases productivity while lowering total cost of ownership. The value of accelerated computing is to do more with less. For example, we have SDKs, toolkits, and frameworks spanning ETL or extract, transform, load the data, generative AI, and inference use cases that provide GPU acceleration. Second is enterprise grade security, stability, manageability, and support. As AI rapidly evolves and expands, the complexity of the software stack and its dependencies grows. NVIDIA AI Enterprise is designed to offer enterprise-ready solutions for mission-critical AI that businesses run on. Enterprise support for production deployments through the full backing of NVIDIA experts globally with SLA response times. Prioritize fixes. All support tickets submitted by NVIDIA AI Enterprise subscribers get the full attention of NVIDIA solution engineers and development teams over all else. Third, cloud native and certified to run everywhere. The NVIDIA AI Enterprise software is containerized. Containers allow portability, which is how enterprises can have a consistent environment, irrespective where they choose to deploy, enabling multi-cloud and hybrid cloud environments. NVIDIA AI platform consists of three important layers. Accelerated infrastructure that provides accelerated computing to power entire AI technology stack. AI platform software, which is NVIDIA AI Enterprise Software Suite for production AI, and AI services for enterprises to easily build AI applications leveraging state-of-the-art foundation models. The NVIDIA AI platform runs on accelerated infrastructure on Microsoft Azure. NVIDIA AI Enterprise is the runtime that is used across the full end-to-end AI workflow. Starting with data prep, you can use NVIDIA Rapids to accelerate your data prep job on GPUs. The next step in the AI workflow is to train and customize your model. A multi-node AI training job can be submitted on DGX Cloud to perform training at scale. In addition, certain toolkits like Tau toolkit or PyTorch and TensorFlow, which are GPU accelerated, can be used directly within NVIDIA AI Enterprise. The last step is model optimization and deployment. Model optimization can be done using NVIDIA TensorRT, and once the optimized engine is created, it can be deployed at scale using the Triton Inference Server. All of the optimizations and deployment can be done within Azure and its services. As NVIDIA accelerates end-to-end AI workflows, for many enterprises, maintaining a consistent, secure, and stable software platform for building and running AI is a complex and resource-intensive task. Consider the foundation software used in AI as shown on the slide. The graph represents NVIDIA AI Enterprise foundation layer from data processing, training, optimization to deployment. The graph shows unique software packages, which are represented as dots, and dependencies as lines, which include over 4,000 unique software packages, 64 of which are NVIDIA CUDA libraries, and more than 4,471 are third-party and open source software packages. With this number of software packages, the risk of introducing security vulnerabilities is very large. Understanding all the dependencies between these unique software packages to maintain API stability is another challenge. A change in any of the third-party and OSS packages can require a subsequent change in a dependent API, which can break the stack. This web of dependencies makes it nearly impossible for enterprises to use the latest open source versions of their deployments. NVIDIA AI Enterprise addresses the complexities of organizations trying to build and maintain their own high-performance, secure, cloud-native AI software platform by offering continuous monitoring of vulnerabilities, regular timely patching of critical and common vulnerabilities and exposures, which are called as CVEs, maintaining the APIs through API stability, enterprise support with service level agreement or SLAs, and access to the NVIDIA AI experts. On this slide, we shall see the entire stack with DGX Cloud and NVIDIA AI Enterprise. DGX Cloud is an AI supercomputer for multi-node training, now available on Azure Marketplace as a SaaS offering. It provides enterprises immediate access to the infrastructure and software needed to train advanced and customized large language models. DGX Cloud includes NVIDIA AI Enterprise software. Please check out our Ignite session on DGX Cloud to learn more. NVIDIA AI Enterprise is optimized and certified to run on Microsoft Azure Cloud accelerated infrastructure. The NVIDIA AI platform offers an end-to-end AI solution on Azure Cloud. Enterprises needing to train a large and customized LLM may start with DGX Cloud. Once their model is trained, customers can use NVIDIA AI Enterprise, which is again the same software used in DGX Cloud, to deploy their enterprise model through various options on Azure. The NVIDIA AI Enterprise Virtual Machine Image, or VMI, is currently available on Azure Marketplace for customers looking to deploy through a VM with the flexibility of using the software on demand or through a longer-term private offer. AKS, or Azure Kubernetes Service, support with NVIDIA AI Enterprise will be available soon for customers looking to do inference with a managed Kubernetes service. And just announced is our Triton production branch integration into Azure ML managed endpoints and also NeMo models and framework hosted in the Azure ML model catalog. We will discuss the integrations into Azure ML a bit more in detail in the next section. In this section, I will share the new integrations just announced at Ignite with NVIDIA AI Enterprise in Azure Machine Learning. The Triton Inference Server production branch release is now generally available through Azure Machine Learning managed endpoints. Triton is an open source inference serving software that streamlines AI inferencing. It's used by over 40,000 companies in production deployments of their AI models. It supports multiple deep learning and machine learning frameworks, including TensorRT, TensorFlow, PyTorch, Onyx, OpenVINO, Python, Rapids, and many more. Triton Inference Server supports inference across cloud, data center, edge, and embedded devices on NVIDIA GPUs. It delivers optimized performance for many query types, including real-time, batched, ensembles, and audio-video streaming. In addition to Triton's optimization features like dynamic batching, concurrent model execution, pipeline ensembling, the production branch of Triton, which has been integrated in Azure Machine Learning managed endpoints, comes with enterprise-grade security, CVE patching on regular cadence, and API stability. NVIDIA AI Enterprise Production Branches. These production branches are exclusive to the NVIDIA AI Enterprise software suite. Production branches offer API stability, a guarantee that the APIs won't change, monthly CVEs, which stand for common vulnerabilities and exposures, patches and bug fixes, two branch releases per year with a 9-month lifetime for each branch, with a 3-month overlap between the two production branches. Apart from production branches, there are feature branches as well as long-term support branches also available under NVIDIA AI Enterprise subscription. As mentioned in the previous slide, NVIDIA AI foundation models and 𝗲𝗏 framework are now integrated within Azure Machine Learning Model Catalog. The screen capture in the bottom right corner is an example of what the model catalog currently looks like. Soon you will be able to find the NVIDIA foundation models along with the 𝗲𝗏 framework within the model catalog. The 𝗲𝗏 models offer optimizing performance for production use cases at scale. You can leverage the foundation model out of the box for deployment, or you can fine-tune and customize these models on your custom dataset. The 𝗲𝗏 framework comprises of training and inference containers that are leveraged under the hood for optimizing these models, performing fine-tuning, as well as for deployment. We discussed generative AI earlier in this session, and NVIDIA 𝗲𝗏 is our solution for customizing LLMs for generative AI. Included as part of NVIDIA AI Enterprise and now available on Azure Machine Learning Model Catalog, NVIDIA 𝗲𝗏 is an end-to-end cloud-native framework for building, customizing, and deploying generative AI models. Some of the prominent features of 𝗲𝗏 framework are data curation. The 𝗲𝗏 framework simplifies complex process of data curation by effectively extracting, deduplicating, and filtering information from massive amounts of unstructured data. Optimized training. What makes 𝗲𝗏 truly unique is its ability to efficiently use GPU resources and memory across tens of thousands of nodes, leveraging distributed training with advanced parallelism techniques. Model customization. The magic of 𝗲𝗏 unfolds as you explore its customization capabilities. Once your foundational models are trained, you can easily adapt them to a variety of tasks. Adding functional skills focuses on specific domains and implement guardrails to prevent inappropriate responses. NVIDIA 𝗲𝗏 framework exposes certain techniques for customizing the large language models on your custom data. These techniques include PEFT or parameter efficient fine-tuning, supervised fine-tuning, RLHF or reinforcement learning from human feedback, and many more. Deployment at scale. 𝗲𝗏 integrates seamlessly with NVIDIA Triton Inference Server as well as its backend to accelerate the inference process. 𝗲𝗏 delivers low latency and high throughput inference on the large language models deployed using the 𝗲𝗏 inference container. It also comes with comprehensive support. As part of the NVIDIA AI Enterprise software, 𝗲𝗏 is backed by a team of dedicated NVIDIA AI experts, providing unparalleled support and expertise. In summary, to accelerate building and deploying AI on Azure, we have integrated NVIDIA AI Enterprise in Azure ML to offer a quick and seamless solution. NVIDIA Triton is now generally available within Azure ML managed endpoints. The production branch of Triton that's part of NVIDIA AI Enterprise is a container which is fully supported by NVIDIA with 9-month release stability and monthly CVE patching and bug fixes. NVIDIA AI foundational models and NeMo Framework Toolkit is now available within Azure ML Model Catalog. This includes the new family of NVIDIA Foundation models as well. The NeMo framework allows for customization, optimization, and deployment through Azure ML UI.